Hello, it's Keith here, and this is lesson 22 of the simple series of my 6502 assembly programming tutorials. In the simple series, we create a single file each time that does a simple task. Today's task isn't so simple. We're doing bitmap clipping again. I'd call it sprite clipping, but people would argue it's possibly not a sprite. But anyway, what we're doing is we're creating this little Chibico character, that's my mascot, and we're building it out of tiles. So we've built a grid of custom characters effectively that are making this graphic here. And the clipping example allows the graphic to be partially off the screen. So I'm controlling it with my joypad, and you can see we can move our character around the screen, and the character can go partially or even entirely off the screen. Now the bitmap drawing example is based on the previous simple series example, as is the joystick reading routine, so we're not going to cover those today. What we are going to cover is this new cropping routine that is cropping the tile graphic, and then when the tile graphic is drawn to the screen, the parts that aren't needed are being removed. Now to do this, we've needed to change the way we're calculating things logically, and actually this example is being ported to a variety of different systems, and so the way we're calculating things is based on that multi-platform concept. So let's go over to the theatre screen and let's have a look at the image we need to see. So this is the way we are doing our coordinates within this piece of code. So basically our tiles are effectively 8 by 8 pixels, and the way we're calculating our coordinates is based on a 256 by 192 screen. That's our sort of ideal resolution, if you will, even if the VIC-20 can't do that. And we need to have a logical area which is outside the visible area of the screen, so our sprite can be partially off screen. And you can see here we've got this Chibico example here, and in this case only the top right hand corner is on the screen and the rest is off the screen. So the coordinate system I use is a logical one, where one logical unit is 2 logical pixels. So a tile is effectively 4 logical units times 4 logical units, and our sprite is going to be made up of effectively 6 by 6 tiles. So that is 48 by 48 pixels, or 24 by 24 logical units. So that's how we're doing our calculations. Now when it comes to actually drawing the graphics to the screen and working out what changes we need to make to that drawing, we're going to need to do some calculations and alter our graphic accordingly. So if we just go over to another screen here, if we just go over here, this is where we're going to discuss that. Now if we imagine our screen as being something a bit like this, but maybe a bit better drawn, and then we've got some kind of sprite which we'll draw a circle here, but of course our sprite graphic is in a square or rectangular area. So we've got our sprite here, and our sprite in our previous example was able to move around the screen provided it was always on the screen, but this time we're going to be able to allow it to go partially off the screen, or even entirely off the screen. And so we're going to need to make some calculation differences depending on where it is. For example, if it's in this position here, we're going to need to start drawing at a different position. We'll need to skip all of this bitmap data and change the height to this. But that's what we would do if it's off the top of the screen, but that's going to be different to what we're going to do if it's off the bottom of the screen, because if it's off the bottom of the screen, we just need to change the height. Well, that's fine for the bottom of the screen, but what if it's off the left-hand side of the screen? Well, in this case, we're going to need to skip some of the starting bytes, and then after each line, we're going to need to skip these bytes here. Well, what about if it's on the right-hand side of the screen? Well, the procedure is going to be different again. This time we're going to need to skip nothing for the starting pixel, which is going to be here, and we're going to need to skip this part here. Could be even worse though. It might be a combination of the two in these corner cases. And fun fact, the Chibi game had a sprite clipping routine, but it didn't work so well because the corner cases didn't work. It would actually make mistakes and glitch out. This version does work though in those cases, so it's actually better than the code in Chibi for sprite clipping, and that's because I've actually got better at programming, which is a miracle possibly. Anyway, that's what we're going to look at here. That's the example you can see on the screen here, and as I say, it I believe works in all cases. You can go to my website as always, download the source code, and as I always say, you're welcome to use it in any way you can gain benefit from, even if it's in some way commercial. Anyway, let's go over to our source code and let's take a look. Okay, so here's the code we're looking at today. Now the first thing we're doing here is we're defining our screen. Now we're defining a logical screen. We're effectively defining one that is 22 tiles by 23. That's 88 by 92 in logical units. Now that's the size of the screen that I've configured here. It's not the same as my 256 by 192 pixel screen would be, but that's because the VIC-20 can't do that. So we've had to use a smaller size. Now we've got various bits of code here that are very similar, if not identical, to previous examples, defining the custom characters that we're using for our tiles, reading in the joystick. I've covered those in the simple series before, so if you need to know how to do that, please see the other simple series examples. The first thing we're going to look at in today's example is this updated drawing routine. Now there's two versions. One is going to draw the Chibico character to the screen, which uses custom character 0 onwards, and one just blanks out the Chibico, which uses custom character 36 onwards. And we're loading those into a 0-page entry ZIL. ZIH is used for the color. We're also defining the color. Now the X and Y position are in 0-page B and C, and we're defining the width and height in H and L here. Now these are 24 by 24, but that's logical units. The bitmap graphic is 48 by 48. So as I say, logical units is always 2 pixels per logical unit. Now it's the do crop routine that calculates all of the cropping work, and once we run this, it will set or clear the carry. If the carry is set, the entire graphic's off the screen and we don't want to draw anything. So that's what we're doing there. So we'll take a look at this cropping routine first, and we'll see how that works. Okay, so here's the start of our cropping routine, and we're starting by loading Y with 0. We're clearing D and E, which are some temporary variables, and we're setting Sprite Hclip to 0. Well, what's Sprite Hclip? Well, this is to handle the cases where the graphic is partially off the screen on the left or the right, because after each line we would need to skip this part here, or if it's on the other side of the screen like this, we would need to skip this part here. So that's what this Hclip is for. It's for the horizontal clipping after each line. So that's what we're going to be doing later on. But at this point, we're assuming it's going to be 0. So we're just initializing it to 0 here. Then what we're doing is we're going to calculate the needed cropping first from the top and bottom, and then from the left and the right. So what we're doing here is we're loading the Y position of our graphic, and we're subtracting the minimum logical visible Y pixel, which is the top of the visible screen. Now if this goes below 0, then our graphic is partially or entirely off the screen, but if it doesn't, then our graphic must entirely be on the screen, at least in the vertical axis. So what we're doing here is if we've not gone below 0, then we are over the visible screen, so we can skip over the next stage. But if we've gone below 0, part of our graphic needs cropping. So we're converting that from a negative to a positive, and then we're basically averaging it out to a tile. And then what we're doing next is we're seeing if the number of tiles we need to remove is the entire height of the graphic, because if it is, then we're entirely off the screen. So in that case, we would go to this all off screen routine, which would set the carry and then return, because there's nothing on screen to draw. If that's not the case though, then we've now calculated the amount we need to remove from the top. So we're storing that in ZE for later on. And we're setting the accumulator to 0, which is stored in C, which is the new Y position. Now, in the case that it's partially off screen, we're going to start drawing from the very top of the screen. But in the other case, we've now effectively subtracted the minimum logical Y coordinate. And so now we've actually got the logical position relative to the visible top of the screen. So either way, we want to update that. We now know the top of the drawing position. We're now going to calculate the bottom. So what we're doing here is we're adding the height of the graphic, and we're then comparing that to the logical height of the screen. Now, if this has caused us to go over the bottom of the screen, then this means we need to crop part of the bottom off. Otherwise, we skip over. So if we get here, then we need to crop off part of the bottom of the screen. So we're calculating the number of tiles, seeing if the number of tiles we need to remove from the bottom is the entire height of the graphic. And if it is, we give up. If it's not, we store the new number to remove from the bottom in D. So D now is the number to remove from the bottom, and E is now the number to remove from the top. Okay, so we might need to do some cropping. So we now take those two values, add them together, and if the value of that is 0, then there's nothing to take from the top or the bottom, so we simply skip. Otherwise, we negate that and then add it to the height, and this is now the new height, subtracting anything we need to take from the top or the bottom. Now, that's okay for calculating the height, but in the case where the graphic is partially off the top, like this, then we need to remove part of the graphic from the top there. So we're going to have to do that next. That's what we're doing here. So what we're doing here is we are taking the number of lines to remove from the top and converting that into a tile count by shifting it to the right twice. This is converting the number of logical units into the number of logical tiles. What we then need to do is work out the number of tiles in each line, and we're doing that by taking the width, shifting it to the right twice, and again this is now converting it into the number of tiles that we need to remove. And so what we're then doing is we're adding that to IYL, which is the starting tile number, and this is now calculating the number of tiles we need to remove from the start of the drawing. So we're going to effectively skip part of the tiles that make up that Chibi-ko character. So this will now remove the lines from the top of the graphic. And once we've done that, we've now effectively calculated the correct starting position of the graphic in the vertical axis. And we're now going to do the same for the horizontal axis. So what we're doing here is we're clearing D and E, our temporary variables. We don't need the old values again. We're going to recalculate them for the horizontal axis. And we basically do the same thing for the horizontal axis. So we're taking the drawing X position here. We're subtracting the minimum visible logical pixel position here, and if that's gone negative, then we're effectively partially off the left hand side of the screen like that. So again, we need to calculate the number of pixels to remove. So we negate that, we compare it to the width of the sprite, and if we're removing the entire width, then we're completely off screen. If we're not, then we are converting that into a tile number, and so we're storing that in ZE for later on. Now again, if that's the case, we want to start drawing from the far left, so we are now updating our drawing position to the far left here. And then what we're doing next is just like before, we're adding the width of the sprite and we're comparing it to the maximum width of the visible screen. Now if that's gone over, then we need to remove part of the graphic from the right hand side. It must be somewhere like this. So that's what we're going to do next. We're storing the amount to crop from the right hand side in ZD here. And once again, ZE now stores the left hand crop and ZD now stores the right hand crop. We add those two together and see if we need to take anything off the sprite. Now, whether the sprite's on the far left or the far right, after each line we're going to need to skip some blocks, and so this is the Sprite Hclip. So we're effectively adding the two together in logical units, converting that to a tile count and storing that tile count to skip in Sprite Hclip here. What we now need to do is update the width, and so we're negating the amount that we're removing, adding it to the width and storing that new width unless we've actually reached 0, in which case we're just going to return. So we've now calculated the width, but we do need to, in the case of being at the far left, remove some of the blocks before we start drawing the first block of our character. And so once again, we need to update IYL. And so what we're doing here is we're taking the amount to remove from the left, which is in logical units, converting that into a tile count, and there's 4 logical units per tile, so we're shifting to the right twice to do that. And we're then updating IYL, which is our first drawing tile here. Now, we've now calculated all of our cropping and updated our starting position. The final thing we want to do is we want to convert our logical coordinates into our physical coordinates, which is a tile count effectively in this system. So we're shifting to the right the starting X position and the starting width and the starting Y position and the starting height, shifting them to the right twice, effectively dividing by 4 in all cases, which converts them to a tile number and a tile position. And that is the end of our cropping. So we've now done our cropping and we've now calculated whether we actually have anything left to draw. If we've got nothing to draw, we're going to return, but if we have something to draw, we're now going to use getVDPScreenPos, which will convert our X and Y position in horizontal tiles and vertical lines, and this will calculate the VRAM address of the data that we want to write to. Now our VRAM for our characters, or tiles as we're treating them in this case, is at 1E00 in hexadecimal, and each of those tiles has a matching color attribute at 9600 and onwards, and we're going to change those now in this code. So basically what we're doing here is we're calculating the first VDP line of our character here, and then what we're doing is we're taking our tile number, which is effectively the custom character we want to show, and we're storing that into VRAM at ZDE, which is the VRAM address of the tile that we want to change. So we change that, we're then backing up the DE pair here, or just D in this case actually. We're then adding 78 to the offset, which is moving us to the 9600 range, which is the matching color attribute for that tile, and we're then updating that with IYH, which is the color attribute. We're then restoring ZD, which is pointing us back to the VRAM, and then we're repeating, and we're doing that for the whole horizontal line. Once we've done a horizontal line, we're then going to have to move down a line. But first of all, what we're doing here is we're checking to see if there's any characters that we need to skip, and we will need to skip them if we're partially off the left hand or the right hand of the screen, as I said before. If we are, we're adding this to our starting position in IYL, which is going to be the next tile number that we're going to show to the screen. We're then updating our vertical position in VRAM. We're adding 22, which is the number of characters on each line horizontally, so that effectively moves us down a line. And we're repeating for the next line of our Chibico bitmap, and so that's how we're drawing our Chibico bitmap to the screen. Now really, I think the only thing that's particularly changed in this after this get VDP screen pos is this part here, which is handling the removing of the tiles that are unused because of the cropping. The rest is basically the same here. And as I say, that's how we're able to draw our simple little character to the screen and allow the character to be partially cropped. As you see, it's already very much off screen here, but in the case of it being at the far left or the far right here like that, that's when this Sprite Hclip will come into play. Otherwise, it's just simply a case of removing some lines from the top or removing some lines from the bottom and changing the height accordingly. And so there we go. As I say, please go to my website and download the source code and try it out yourself. And if you liked what you've seen today, please make sure you like and subscribe, because we're going to be coming back to the VIC-20 later on, because I've got another example planned where we're going to be doing a basic tile map effect. We're going to be drawing a tile map and we're going to be allowing some basic scrolling. So if you want to know how we can maybe do that kind of thing and also handle this kind of character graphics at the same time, please follow on for that, and hopefully you find that interesting. Anyway, thanks for watching today, and goodbye.